I'm Guang, 50 years old. In this lesson, we'll take a look at this question over here. And this question is double integration around or across this range d, y, dx, dy. Alright? And d is the overlapping area of x squared plus y squared small equals to x and x squared plus y squared small equals to y. So firstly, of course, we will have to know what kind of functions are these. Of course, you might recognize them as circle functions, but then you will really need to know how exactly do they look like. So how about we take a look at x squared minus x plus y squared smaller or equals to 0. So we want to use completing square on this. Now x minus half squared plus y squared is smaller or equals to 2. So here you have an extra 1 over 4. That means you need to have 1 over 4 over here. Alright? Okay, so this is essentially what you have for your first function. So you can do the same for your second function. So what your graph will look like is, here is the x-axis, here is your y-axis. This is your origin. Alright, so we have two circles. One of the center is half 0, the other of the center is 0 half. Right, now, well, what's so special about this? Now, we can have, let's say these two are their centers. So you're going to have, oops. So this is your circle for x squared plus y squared smaller or equals to y. And this is your circle for x squared plus y squared is smaller or equals to x. And of course your overlapping area would be here. Alright, so for this overlapping part, then we can determine in what way can you integrate them, whether with respect to x first, with respect to y, from which function to which function. Alright, so of course if we want to integrate, let's say with respect to y first, for example. So if you want to integrate with respect to y first, what would you need? Now, integrating with respect to y first, we will have to determine both of these functions in terms of y, right? And of course you need one-to-one functions, so you have to be aware of that. Now, of course the other one would just be x squared plus y minus half squared is smaller or equals to 1 over 4. So y, now you need this function. So since here is this part, and you can determine that y, since this is to the right, or should I say, since this is according to y, that means it is a below part. So since this is a bottom, then you're going to have half minus square root 1 over 4 minus x squared. Alright, so this is the function for the part below. Well, how about your part for the other circle? Now for your other circle, what you're going to see is y is equal to, so we're going to have square root 1 over 4 minus x minus half square. Alright, so that means here we have y is equal to half minus square root 1 over 4 minus x squared. Well here, or if you really want, then it's all the way inside. So this part is y is equal to square root 1 over 4 minus x minus half squared. Alright. So now we can determine where we want to integrate from and to. So integrate, that means we're doing with respect to y first. So y dy dx, and y, since it is integrating upwards, then you're going to have half minus square root 1 over 4 minus x squared to square root 1 over 4 minus x minus half squared. Or if you really want to change that, then it would just simply be x minus x squared. So x, what is it from and to? So x, since you can have, it is just between this part, which means it is from 0 to half. And why is this half? Well, you just either equate your two different equations and get that this is the half point, or you can just think about it and you realize that their radius is half. Right, so x is from 0 to half. Right, so what else are we going to have? How about we start integrating them? Which means you'll see half, then integrate from 0 to half. So you have y squared, then substitute in the values half minus square root 1 minus 4, or 1 over 4 minus x squared, and square root x squared, wait, this isn't, x minus x squared, and dx. Right, so we have done the integration for the first time. Now we can take a look at how we can integrate it a second time. So half, integrate from 0 to half. Now you substitute your upper boundary, you're going to have x minus x squared, and then minus half minus square root 1 over 4 minus x squared squared. Alright, so this is what you're going to have. Now we can expand the term behind. So x minus x squared minus 1 over 4 plus square root 1 over 4 minus x squared, and then minus 1 over 4 plus x squared, then dx. Right, so this is what we are going to see. Right, now since we do realize there's a negative x squared and a positive x squared, we can basically cancel out the two. So we'll have half, integrate from 0 to half, square root 1 over 4 minus x squared plus x minus half dx. Alright, so now we can integrate for your second two terms. But for your first term, you're still going to have to change it. So your first term is 1 over 4, integrate from 1 to half, square root 1 minus, so you take out the half, which means you're going to have 2 x squared. Is this correct? Since if you put in a half, you're going to have multiplied by 1 over 4, multiplied by 1 over 4. Yes, you get the original one. Right, then dx. So for a second term, you're going to have plus 1 over 4 x squared, integrate from 0 to half. And your last term, which is minus 1 over 4 x, substitute 0 and half. Right, so the first term, we will need to use a trigonometric substitution. Well, we'll have to let 2x be equal to, you can choose whether to use sine or cosine, since this is 1 minus something squared. So how about, let's say we let this be sine theta. So that means we'll have 2dx is equal to cosine theta d theta. Alright, so how about our range for theta? So when you put in x is equal to 0, sine something is equal to 0, so you can have sine 0 is equal to 0, and this is from 0 to, so when you put in half, which means you have 1, so you can just have sine half pi, since it is equal to 1. Right, so this is a kind of trigonometric substitution that we can use. So we're going to have 2. So we will need a half, which is 1 over 8. Integrate from 0 to half pi. So 1 minus sine square theta is going to be a cosine theta. But cosine theta, from this part, when you change dx into d theta, you have another cosine theta. So you have cosine square theta, and then d theta. So for the rest of these parts, we can basically try to calculate them already. Well, the first term, you're going to have plus 1 over 4 multiplied by 1 over 4, which is 1 over 16. And your second term, or should I say your last term, is 1 over 8. Alright, so we take a look again at the first term. So the first term, we can use your double angle formula, where you have 1 over 16, integrate from 0 to half pi, and you're going to have 1 plus cosine 2 theta, d theta, and minus 1 over 16. So your first part, you can once again calculate it. So theta, substitute in 0 and half pi, and then plus 1 over 32 sine 2 theta, substitute in 0 and half pi, then minus 1 over 6. So this term, you'll have pi over 32. Or for this term, since you have sines pi and sine 0, that means this term is 0, so minus 1 over 16. You can also choose to combine them into pi minus 2 over 32, but that's really up to you. Right, so this is the answer you get for this question. Right, so how about let's take a look at what kind of methods we used. So in this question, of course, generally you would want to start from looking at what its boundaries look like. In this case, it is 2 circles with an overlapping part. So the radius are the same, it's just that the center points are different. Now, with that information, we should find what are its different functions for its different parts, since we need to know that those different parts in order to integrate. And of course, since we do need a one-to-one function. Right, so after we find out what those are, we can put them in as its boundaries, start integrating, and then make a trigonometric substitution, use your double angle formula, and you can get your final answer. Alright, so I hope for this question, you can understand everything so far. I will be ending this here, and thank you for your watching.